Let us study about an AC circuit containing a pure resistor. Okay, there's only one resistor. Let's see the picture how to draw it. Okay. So now we have a circuit like this way. Okay. There's an AC source connected to a resistor. Okay. Just one resistor only, nothing else. This is an AC source here. So this AC source gives a voltage here. V is equal to Vm sine omega t. Okay, this is capital Vm. So let me write the equation one more time. V is equal to capital Vm sine omega t. This is the voltage that's given. This is a peak value. Okay. So this is a equation 1. Okay. Now what happens? We give a voltage here. There will be potential drop across this thing. Okay, resistor here. This potential drop we can write as VR. Okay, that's a potential drop across the resistor. So potential drop across the resistor. Okay, potential drop across the resistor. Okay, potential drop across the resistor we can write as this one VR. Okay, so VR is equal to, use Ohm's law. Okay, and we see there's a current going inside. Okay, the current will flow in alternate directions. Okay, the current we say I, the current I will flow in both the directions here. Okay, because alternate current here. Okay, the current is I into R resistor. This is using Ohm's law. Okay, so from Ohm's law. Okay, so now next we'll see how to get the equation for this. Okay, so now let's use Kirchhoff's law. Okay, using Kirchhoff's loop rule. Okay, that's the voltage rule we study now. Okay, this Kirchhoff's loop rule, sorry. Okay, or the voltage rule also we studied. Okay, second rule, both are all the same only. So what does it states? It states that the product of the currents and EMF or current and resistance in the circuit is equal to constant. Okay, see exact definition here. Okay. It states that the algebraic sum of the potential difference in the closed circuit is 0. Okay, so the algebraic sum of the potential difference, that means this one V. Okay, voltage will be 0. Let's see this now. Okay, so algebraic sum of the potential differences. So this is the potential difference given by the source here V. Okay, and what happens, that will be used by this one. Okay, by the resistor. So minus VR. Okay, that's equal to 0. That's algebraic sum is equal to 0. Okay, now what happens is we have to substitute the values here. Okay, substitute values. Okay, so substitute the values of V. That is what we get here, capital Vm sine omega t minus VR is what we get here, I into capital R. That's equal to 0. Take this minus IR to the right side, become plus. So we get here Vm sine omega t is equal to I into R. Okay, we need to find I only. So bring this R down. Okay, I'll bring the R this side. So we get here Vm by R sine omega t is equal to I. Rearrange, right? So we get here I is equal to Vm by R sine omega t. Okay, now we can say that V by R, okay, is equal to I using Ohm's law again. Okay, so that here it is capital Im. Im is equal to Vm by R. Okay, that equation I am going to use here instead of this. Okay, so we get here I is equal to Im into sine omega t. Okay, so this we got here, current. Okay, this was equation 1, this is equation 2. Okay, now what we see is from equations 1 and 2. Okay, compare that equation 1 and 2. What we have is this is Vm sine omega t. Okay, and this is also Vm, sorry, Im sine omega t. Okay, so we can say that there is no phase difference. Both the voltage and the current are in phase. Okay, let me write on this side here. Okay. So from equations 1 and 2, okay, what happens is current and voltage are in phase. The voltage and current are in phase. Okay, it's very important. In phase, I'll write together. In phase. That means voltage and current will change together. Okay, let us see how they change in phase using the phasor diagram. Okay, so phasor diagram is very useful for us. Okay, let me rub out all this and draw the phasor diagrams now. So let us see how to draw the phasor diagrams for both the things, that is voltage and current now. Okay, so let us see how to do that. So first let me draw the phasor diagram for the voltage diagram. Okay, the wave diagram for the voltage. So voltage changes like this way. So 0, pi, 2 pi. Okay, that means pi is 180, this is 360, 2 pi. Okay, so this is the voltage. Let's see how to draw the phasor diagram for the voltage. Okay, so what you do, you put dotted lines like this way from here. Okay, or we may take another any point here. Suppose I take this point here. Okay, so this is a voltage graph. Okay, I put dotted lines like this. Okay, to this side. Okay, so this side we have to draw the phasor now. Okay, then let me draw the phasor now. So for voltage, you see the phasor will be like this way. Okay, so this is the phasor diagram for the voltage. Okay, now let us draw the diagram for the thing that is a current also now. Okay, so current I'll draw using this color. Okay, they say the current and the voltage are in phase. That means if the current voltage increases, current also will increase similarly. Okay, so you can see that like this. I'll draw using this color here, green color. Okay, so this is a current graph here, I. Okay, this graph is current here. So at the same time, okay, current and voltage will rise and fall at the same time. Okay, so down, okay, you see that here it's a straight to it. Okay, I put dot here, and I will bring a projection here. Okay, so if you draw a projection here, you hit this graph here. Okay, this point. So the current phasor also you can draw exactly on the voltage phasor. Okay, so this is the phasor for the current. So current and the voltage are in phase. Okay, so that's what. If voltage increases, the current also will increase similarly. Okay, now let us draw the amplitudes here. Okay, let me mark it here. This side we will get here, that is V. I'll go that side right here. Okay, we'll get here Vm sine omega t. Okay, that's for the voltage. Okay, and then for current here, okay, this part will be Im sine omega t. Okay, so by using these things we have drawn very easily. Okay, let's mark also. This will be OA, okay, and this point is B. Okay, so we can say that OA is what? OA is the maximum voltage, that is the peak value, that is Vm. Okay, and then OB is equal to the maximum value of the current here, that's Im. Okay, so we already learned now the phasor will be the maximum, the length of the phasor will be the maximum value of the voltage or the maximum value of the current here. Okay, so it's so easy things only, just need to draw and see that. Okay, thank you for watching.